So welcome back to my channel, computing underscore teacher, and this is the second video in the topic for IBDP Computer Science, computational thinking and problem solving topic. Okay, so in the previous video we had seen what are the different ways algorithms can be represented. So now in this particular video we are going to move forward and we will be discussing about what are data types. Okay, so data types. So as the name suggests, data type. So what's the type of the data, right? So if we try and draw an analogy between the real life scenario and the programming world, if you fill up a form, normally there will be a section where you would be expected to fill in your gender. Okay, so what are the genders that we fill in? Either a male or a female. All right, so this is how you are going to be identified in the real world, right? Whether you are a male or a female. So this describes the properties, this describes the characteristics of you, whether you are a male or a female, right? However, we know that our computers are dumb machine. All right, so we need to explicitly state to the computers via our programs that what the particular data that we are providing is belongs to the type of, okay, whether it is numbers, okay, whether it is numbers or it is an alphabet. Okay, it is an alphabet or the letter from the alphabet, rather a letter from the alphabet, right? So the program needs to know so that it can identify and work accordingly. All right, so now let us see what are the different data types. Okay, so basically the data types are more or less similar in all the programming languages, where some have a very confined and a limited number of types of data that you can work with, while some have a wide variety of data types. Okay, so let's first see the categories into which a data type, the data types can be divided into. Okay, so basically data types can be divided into two types. One is the numeric type. Okay, one is the numeric type and the other one is the non-numeric type. Okay, non-numeric type. Okay, so as the name suggests, numeric type, okay, therefore these will deal with numbers. All right, so when it deals with numbers, there are two types. One is the integer type and the other one is the fractional or the floating numbers or the floating. So floating, floating, sorry, spelling error, is the floating sorry. So floating in our computing terms means decimals, okay, or fractions, decimals. So the integers will contain only the integer part, the whole number part, whereas the floating numbers will contain with the fraction, with the decimal, like 5.7, 3.2, something like that. Okay, we'll discuss all of these in detail, how much memory it occupies and how it's going to work, right? Next, in the non-numeric type, we have characters. Okay, we have characters which are which will comprise of the special characters and the letters from the alphabet, single. Okay, not multiple, not a collection, right? Then we have something called as the string. Now the string will be a combination of these characters. All right, and then we have the boolean. Boolean is true or false. Okay, so basically these are the data types that are available. All right, so now what happens is that these are independent of, all of these data types are independent of each other. Okay, they have their own properties, they have their own characteristics. All right, they will behave in their own way. You cannot mix one another, or the string is not going to be dependent on characters, the boolean is not going to be dependent on string, the floating will not be dependent on integer. That means they are all independent. Therefore this set of all these numeric data type and the non-numeric data type, this is called as the primitive data types. Okay, so broadly the data types divided into primitive and non-primitive, the ones that are going to be dependent on. Okay, So if we further classify them, so we will have the primitive type and we will have the non-primitive type. Okay, non-primitive type. So the primitive and the non-primitive, primitive will be independent of any other data type, independent of other data types, whereas the non-primitives will be dependent on others, dependent on other data types. Okay, so the examples of non-primitives are classes, then arrays. We'll talk about all of these in detail, and interfaces. So these are with respect to Java. Okay, because as per our IBDP, we need to concentrate on Java. Okay, right. Now let us come back to our primitive data types, numeric, non-numeric types. Let us understand them, and then we'll go to the non-primitive types. Okay, so now let us understand each one of them. So first we have the integer. Okay, the integer data type. Integer. Now the integer data type are all numbers, whole numbers or integral. Okay, integer numbers. Integers are the whole numbers. Whole numbers. Okay, which means that these are without the decimal part. These are without the decimal part. Okay, so integers will be like 1, 7, 200, 98. So these are all integers. Okay, 98.7, this is not an integer. Okay, this is not an integer. Okay, because it has this 0.7, it has the fractional part. Okay, 0.7. So this is not an integer. All right, in Java programming language, how do we identify int? Int is the keyword that is used to represent the integer data type. So say for example, I want to store the variable x with the value 7. So this is how I write int x is equal to 7. So the Java compiler will identify the memory location by the name x, and it will identify that this is an integer part and 7 is the value that is contained in it. Okay, so this is the data type, this is the variable, and this is the constant. If we look at my previous video, the video number 1, I will share a link in the description. You will understand what are variables and what are constants. So here in this video, I'm assuming that you know about variables and constants. Okay, so this is how, right? So now how much does this integer is going to store a memory location that is required? Okay, so this requires 32 bits in the memory. So Java will allocate 32 bits in the memory for storing an integer type. Okay, so what about if there are the numbers that require less number of memory location? Okay, so for that we have another data type which is byte. Okay, which is called as byte. This byte is going to take up 8 bits. Okay, above the bytes we have short. Okay, we have short. Short is going to take up short. Short, this short is going to take up 16 bits. Oh, sorry, 16. Okay, let me write it clearly. Will take up 16 bits. 16 bits. Then if we want to store something which is larger than short, for that we have the integer. Okay, this occupies 32 bits. Above integer, if we want to store something larger, then we have long integer, and this requires 64 bits. All right, so for byte the keyword is byte, for short the keyword is short, For integer, the keyword is int, and for long integer, the keyword is long. Okay, remember this is small l. Okay, is long. Okay, so this is about the numerical. All right, with the integer values, not with fractional values. All right. Okay. Now, what about the fractional part? Now, for the fractional part, we have the data type which is called as float. Okay, we have which is called as float. All right. Now, this float will hold values like 15.7 with the decimal part 0.7. All right. How is it written? Float is the keyword. Okay. Say x is equal to 15.7. So this is the data type. Again, x is the variable and 15.7 is the constant value. Okay. So this is how in Java programming language we are going to write it. Okay. What about if we want to store a larger values with fractional parts? Okay. So basically, there is another data type which is called as double. double. All right. So float takes up 32 bits. All right. Floats requires 32 bits. Double will require 64 bits. Okay. So if you look at this float and this particular double, these are real type numbers. Okay. They are also called as the real numbers. Okay. Why? Because it has the fractional part. All right. So integer numbers and real numbers. So under that we have two data types. One is float and the other one is double. Okay. Float will require 32 bits and double will require 64 bits. All right. So the keyword that is used for double is double with a small d. Okay. So we write like this in programming language. Double, say y is equal to say 2738.6487 and something like this. Okay. This is going to give us a longer value, longer range rather. Okay. So this is about the numbers. Okay. Without fractions and with fractions. So you have integer, byte, short, integer, long integer, byte 8 bits, short 16 bits, integer 32 bits, long integer 64 bits. For the fractional parts, you have two. One is float, the other one is double. Float will take 32 bits and double will take 64 bits. All right. Now let us come to the other non-numbers, non-numeric data types. Okay. So in the non-numeric data types, you have the first one, that is character. Okay. Character data types. Character data types. Okay. So these are non-numeric. Okay. We have got character data types, first one. So what these character data types store is single character. It shows a single character. Okay. Like A, B, say I want to store the symbol @ I want to store the symbol hashtag. Okay. So these are all single characters, right? But how are we going to store it and what is the keyword that is there? Okay. Now, how it is stored is this. The keyword is char. Okay. char. And the variable as usual. So say for example, the variable that I want to is say letter. Okay. I've created a variable which is called as letter, and in this particular variable letter I want to store this letter A in it. Okay. But what we have to do is we have to enclose this letter A within the single quotes. Okay. Within this single quotes, single speech marks, in other words. All right. So this is how it differentiates that this particular letter A will go inside this variable A. So this one is my variable. This is my constant or the literal. This is the constant or the literal constant value or the literal value. And this one, as usual, is the data type. Is the data type variable and the literal constant. So, say for example, I want to store char. Okay, say symbol. So sym is equal to, I want to store the @ symbol. So this is how I'm going to store. Okay. Now in the memory, what happens is that each and every character that you see on the keyboard, all right, has an ASCII value associated to it. Okay, ASCII is American Standard Code for Information Interchange. All right. Now this is something that corresponds to this letter A, and it will understand and interpret it using its ASCII value. Okay, so it is always beneficial that you remember some of the ASCII values. So the letter capital A to capital Z. Okay, the ASCII value is from 65 to 90. Okay, so capital A is 65, capital B will be 66, capital C will be 67, and so on, and capital Z will be therefore 90. Okay, then you have the small letter A to small letter Z, and this will be from 97 to 122. So small a will be 97, small b will be 98, and so on. Small z will finally be 122. Then the digits 0 to 9. Okay, 0 to 9 is from 48 to 57. Okay, so 48 will be 0. Okay, 49 will be 1, and so on, and the final digit 9 will be 57. And each of these special characters, @ space bar, hashtag, ampersand, all of these will have its own individual ASCII code. So you can actually write a program to print all the ASCII codes. We shall see all of these in our later videos. Okay, so this was the first, which is the character data type. Yeah, and this character single letter data type will require 16 bits. Okay, will require 16 bits of memory. Will require 16 bits of memory. Okay, the next non-numeric data type is our strings. Okay, strings. Now strings is a, a collection of the characters. Okay, in short, in very, very simple terms, okay, is the collection of, it is the collection of characters. Okay, is the collection of characters. Like say for example, the name of this channel, okay, which is computing _teacher. Now if I want to save this in a variable computing _teacher, all right, if you notice, C is a single character, O is a single character, M is a single character, and when all of these are combined together, if you notice, then the underscore is also a single character. All right, each of it will have its own independent ASCII codes. All right, but here I want to collectively put them together inside one variable. I want to store them inside one variable together, computing _teacher. So what I will do is I will put it inside the double speech marks. Okay, this is important. I'll put it inside the double speech marks. All right, and this value I will insert into another variable called as channel, and I will name this as string. Okay, so something that you need to notice over here is that the word or the keyword string starts with a capital S. Okay, it's not with a small s, it starts with a capital S, string. Okay, so when you want to store a collection of characters or the group of characters together, when you want to store more than one character, then you will use this string data type. Okay, so this is going to require more than 16 bits. Okay, all right, now there is a very, very interesting thing over here. Okay, very, very interesting thing. Now we know, say for example, this is 12. Okay, this is the number 12. Okay, this is the number, this is the number 12. What will happen if I write something like this? if I write string num is equal to, and I put it inside double quotes, and I write this string num is equal to 12. Okay. Or say, for example, I take a single character, say the digit 2. So this is a digit, which is again a numeric data type. So technically, I should put it as int x is equal to 2, right? But what I do is I write like this char, say x is equal to, within single quotes, 2. What happens? Do you get an error, or what actually happens? Okay, think for a moment. Yeah, I think you would have got an answer. What would happen? In both these cases, it does not give an error. They are valid. But how are they valid? We just saw that this is an integer. 2. How am I storing it within a single character with a data type char? And how is it allowing me to store inside the variable num as a string variable, as a string data type? Okay. What happens is that when you enclose it within the double quotes, the 12 is no longer the number 12. It has lost its identity as a number. So what has happened is now it will behave like the string 12. So 1 is a character for it, 2 is a character for it, and it will behave like a string. So all the functions that are applicable on a string will now be applicable on this particular number 12. Where do we find a use case? I'll give you a simple use case. If I want to store the phone numbers, okay, we have 10 digits phone numbers along with, sorry, 10 digits of phone numbers along with the country code with the plus sign, right? So in that case, can I store that as a number? No, I cannot store it as a number because it has the plus sign along with it, and it has got a 12 digit or a 13 or a 14 digit number along with the country code and the other local codes and stuff like that. In that case, and moreover, I'm not going to use it as a number. I'm not going to use to add one phone number with another phone number and find the sum of it, or multiply two phone numbers. I'm rarely going. I'm technically not going to do that, right? Therefore, in such conditions, we can store it as a string and we can manipulate it as strings, right? Similarly, when I store char x is equal to 2 within the single quotes, the 2 is no longer a digit. It becomes a character and it behaves just like a small letter A or a capital letter B or a small letter C. It is no longer a number. Okay, so this is no longer a number. It is character. Okay, so this is something very, very interesting when it comes to the string and the character data type. Okay, so basically these are the most important data types that you will actually use. Classes, arrays, and interfaces are certain things that I would not want to talk about in this particular video. They are a little complex to understand at this moment. So these are the primitives and the non-primitive. These are the basically the primitive data types fundamentally used for our basic programming, right? Okay, yeah, we forgot. And the other one is the last one is the Boolean type. Okay, that is also something that will be very, very useful. Okay, and very, very widely used. So Boolean. So what is this Boolean? The Boolean is when I want to store either the value true or I want to store the value false. Okay, if I want to store it true or a false. Okay, so what happens is that, say for example, I want to use a flag kind of a variable which is just an integer, or I want to use a variable which will work as a terminator for my loop condition, that when the when that particular flag turns out to be false, my loop should terminate. Okay, so in that case I will use a variable which is called as a Boolean. Okay, so the keyword is with a small b. Okay, Boolean. Okay, and any variable, say for example flag, Boolean flag is equal to true. Remember, true is a keyword with a small t. So if you write, you cannot use, therefore you cannot use this word true with a small t as a variable. Okay, however, if you write true in Java, then it is not a keyword. It is a, you can use it as a variable or you can use it as a string when you store it inside this. So when you store it like this, it's no longer a Boolean data type, it becomes a string. Okay, and when you write true like this, then it is a Boolean data type. Okay, Boolean constant value. All right, so this is, as usual, is my variable. Okay, this one is my Boolean value, or the Boolean constant. All right, and this one is my data type, as usual. Okay, so basically whenever we are writing a assignment statement, we write the data type, we write the variable, and then we write down the constant value that we want to assign it to. So the two values that are acceptable over here is true or false. So remember, false will again be with a small letter f. Okay, all right. So this was technically about the data types that are used. Okay, now this is how we actually write it in actual programming, Java programming. Okay, but the purpose over here is that how do we write it according to our IBDP syntax for our pseudocodes, when we are writing a pseudocodes according to our IBDP curriculum. Okay, computer science. So here what happens is that we simply write it down as x is equal to 5. So it is understood that x is an integer type of a variable. However, I suggest that you put this double slashes like this and comment it, right? And write x is integer variable. Okay, so this actually is not a mandatory statement, but it is always advised that you write the comments next to your statement. So this actually shows your maturity as a programmer, and it also gives a good clarity to the examiner as to what the value or the variable is going to be. Okay, so this gives, and this will become and this will be useful when you are defining when you're defining arrays. Okay, so when we talk about arrays, we will understand how it uh, works, and how this particular comment statement is going to be useful. Okay, I hope all of you know what a comment is. In short, comment is a non-executable statement which only presents the logic to the reader. So it makes your program readable, okay, more readable for the for another developer who's reading your code. Okay, it is not executed by the compiler. Anything written after this double quotes will not be executed by the compiler. So it will read only till your x is equal to 5 and not any further, because it encounters this double slash. Okay, all right, so that was all in this particular video. I hope you have understood. If you have any doubts, revisit the video once again and get all your clarities. And please do leave your comments. If you like the video, if you want to see something new, please do let me know, and I'll be more than happy to serve you. All right, so goodbye for now. Thank you and happy learning. So if you like the video, also share, like, and subscribe to my channel. Welcome. Bye bye.